All right, today we're getting into a fascinating and really important topic in human health, a side-by-side look at two major parasites, the pork tapeworm, Tenia solium, and the beef tapeworm, Tenia saginata. Now you might think a tapeworm is a tapeworm, but as we're about to see, one of these poses a much more serious threat. Figuring out which is which isn't just for exams, it's absolutely critical for public health around the world.
So, here's how we're going to break it down. We'll start with the basics, defining Teniasis. Then we'll zoom out and look at where these infections are happening globally. After that, we'll get into the nitty-gritty, comparing the anatomy of these two worms, tracing their pretty wild life cycles, and finally, we'll talk about what an infection actually looks like and the big challenges in diagnosing it.
Okay, let's kick things off with Section 1. What exactly are we talking about when we say Teniasis?
So, Teniasis is specifically the infection you get from the adult tapeworm hanging out in your small intestine. And listen, this is a really important point to lock down because it's totally different from a condition called cysticercosis. That disease is caused by the larval stage of Tenia solium, and it's way more dangerous because it can get into your brain and muscles. We'll see why that distinction is a huge deal in a bit.
And here they are, our two main players. They both cause that intestinal infection, Teniasis, but from a public health perspective, they are worlds apart. An infection with Tenia saginata, the beef tapeworm, is generally not a huge medical problem. But Tenia solium, the pork tapeworm, that one comes with the terrifying risk of causing neurocysticercosis, which is actually a leading cause of epilepsy in many parts of the world. So yeah, identifying the right worm is essential.
So let's look at the global picture. The map of where these parasites live really tells a story about things like sanitation, farming practices, and public health. So where are these infections most common?
You can find Teniasis pretty much anywhere, but it's a much bigger problem in parts of Latin America, Sub-Saharan Africa, and Asia. It really boils down to two things. First, sanitation systems that might let animal feed get contaminated, and second, local food cultures that include eating raw or undercooked meat. It's this tricky intersection of public health and daily life.
And this chart just lays it out so clearly. Look at that difference. In North America, the infection rate is super low, maybe about 0.1%. But in some endemic regions, that rate can be 100 times higher, hitting as much as 10% of the population. Just think about that for a second. A 10% infection rate. That means in some communities, 1 out of every 10 people could be infected. That is a massive public health burden. And it's not just about some stomach upset. With T. solium, it means a significant portion of the population is at risk for developing neurocysticercosis, which can lead to seizures and permanent neurological damage.
Okay, now let's get into the anatomy. Telling these two worms apart often comes down to looking at their physical features, so let's put them head to head, or, well, scolex to scolex.
First, let's get our terms straight. The scolex is basically the business end of the tapeworm. It's not really a head, no brain or mouth, but it's the anchor. It's the part that lets the worm latch on tight to the inside of your intestine.
And right here on this slide, you can see the key differences. First, size. It's not even close. T. saginata can be enormous, up to 6 meters long, while T. solium is way smaller. Second, and this is a big one, the scolex. The beef tapeworm scolex is unarmed. It just has 4 suckers. But the pork tapeworm has an armed scolex, which means it has those 4 suckers plus a ring of hooks. It gives it a much better grip. And finally, if you look at the proglottids, those are the little egg-filled segments. The number of uterine branches inside them is a dead giveaway. The beef tapeworm has a lot, 15 to 30, while the pork tapeworm has way fewer, only 7 to 12.
I love this description, the solar appearance. It's so perfect. Those hooks radiating out really do look like rays of the sun. In fact, that's where it gets its name, solium, from the sun. It's the most classic visual clue that you're looking at the pork tapeworm, not its beefy cousin.
Okay, but here's where it gets really complicated. In a real-world clinic, you're probably not going to get the whole worm back. A lot of the time, the only evidence you have from a stool sample is the eggs. So can you use them to tell the species apart?
And the answer is a big fat no. Based on how they look under a microscope, you absolutely cannot tell them apart. They look identical. This is a massive problem for diagnosis, right? You can't distinguish a pretty minor T. saginata infection from a potentially life-threatening T. solium infection just by looking at the eggs. That's exactly why modern methods, like PCR or Copra antigen tests that look for parasite DNA or proteins, have become so important. They're the only way to be sure.
Okay, so we know what they look like. Now let's trace their life cycle. If you want to figure out how to stop these things, you have to understand their journey. So it all starts when a human, the definitive host, eats undercooked meat that has the larval cyst in it. That larva then attaches to the intestine and grows into an adult worm. The adult then starts shedding eggs, which pass out in the person's feces. Now for the cycle to keep going, those eggs have to be eaten by the right intermediate host, a cow for T. saginata or a pig for T. solium. But, and this is the absolute most critical point, if a human accidentally eats the T. solium eggs, they can become an accidental intermediate host. And that's when they develop the dangerous larval infection, cysticercosis.
All right, so let's say someone is infected with an adult tapeworm. What does that actually feel like? What are the signs that you've got a several-meter-long house guest?
Well, what's kind of wild is that for a lot of people, the answer is nothing. Nothing at all. If you only have 1 or 2 worms, you might not have any symptoms. You could be walking around completely unaware you're hosting a parasite.
Now, with heavier infections, symptoms can show up, but they're often really vague things that could be caused by almost anything: a little abdominal discomfort, some pain, maybe nausea or diarrhea. Because there's no unique symptom, diagnosis almost always has to come from the lab, by actually finding eggs or proglottids in a stool sample.
And that brings us right back to the main challenge and the big takeaway from all of this. Since the eggs look identical, just using a microscope leaves public health workers flying blind. You find eggs, but you don't know if you need to focus on pig farms or cattle ranches to stop the spread. And that's precisely why advanced diagnostics are a game changer. By using tools that can specifically identify T. solium, health programs can target their resources exactly where they're needed most, improving pig farming, making sure meat is inspected, and treating people who are carriers to stop the spread of that devastating neurocystic ursicosis.